Okay, Algebra 1, Chapter 9, Section 2. We're already having a little bit of fun. My board recognized them as two different fonts when I went through, so rather than messing around, hey, we're just going to be a little bit different today. No worries. So when you think of things that are dependent on something else, let's say what I wear depends on the weather outside. So the weather itself is independent. It will do whatever it's going to do. My clothing is dependent on that event. Maybe the pressure inside a solid depends on its temperature. So the temperature is completely independent. The temperature is going to be whatever it is. However, if the temperature is higher, the pressure is higher. And so we do this the same with probability. So let's say I have a standard deck of cards, and I'm going to pull out a king. So there are 4 kings in a deck of cards, so that's 4 out of 52, which is 1/13. Again, this is probability of pulling a king. And then maybe I say, okay, I don't replace that. What's the probability of pulling out another king? So in this case, there are only 3 kings left, and because I didn't replace it, there are only 51 options. So I'm going to put that as probability of another king. And so if I don't replace that, the probability is 1/13 for the first one, and it's 3/51 for the second one. So what's the probability of that happening? I take the 2 events and I multiply them together. So I'll get my calculator here. Obviously 1 times 3 is 3. And then 51 times 13, that comes out to be 663. I guess I should have reduced that 3 over 51, my mistake. So this will reduce into 1 out of 221. So out of 221 draws, I would actually one time, theoretically, pull a king twice. Now, things that you're going to see is words such as without replacement. You may also see something like, so I go to Quick Trip, and there are 10 varieties of candy bars. Okay, 10 varieties of candy bars. Let's say 6 are milk chocolate, and 4 are dark chocolate. And so let's say I pick one, and then they might say something like, and I pick one and I eat it. So if I eat the candy bar, then that tells me that it is not being replaced. So this is a dependent situation. My second draw depends on the fact that I ate the first one. So if I pick one and eat it, what's the probability that it is, what's the probability that I pick 2 dark chocolate bars? Okay, so the probability that I pick 1 dark chocolate bar in the first draw is 4 out of 10, because there are 4 out of the 10 total, so that's 2/5. The probability that I pick one on the second draw, there's only 3 to choose from this time, and there's only 3 that are dark chocolate, and there's only 9 candy bars left, so that's 1/3. So I take those 2 events and I multiply them together, and the probability of me pulling 2 dark chocolate bars after eating one of them is 2 out of 15. And so that's pretty short and simple, about 5 minutes. Tomorrow we'll have to look at just identifying whether an event is independent or dependent, and then we'll have a few actual problems. So that's chapter 9, section 2, independent and dependent events.